Dear students, in this video I am going to continue types of chemical reaction. In the previous video I have explained two types of reaction. One was combination, other was exothermic and endothermic, that is single type. Heat is released is exothermic, heat is absorbed is endothermic. Now we are going to see decomposition reaction. Reaction in which a single reactant breaks down to produce two or more simpler products, in which we can have the formula AB give rise to A plus B. As similar as that is A plus B give rise to AB is combination, and opposite is AB give rise to A plus B is decomposition. Okay, decomposition will not take place without help of any type of energy, like it uses heat energy, it uses light, or uses electricity, because decomposition reaction requires energy in any form so that its compound or reactant can be decomposed easily. So we have, if decomposition is taking place in presence of heat, it is called thermal decomposition. Examples are given. If it is taking place in the presence of light, it is called photo decomposition. Again, examples are given. These are very important examples. These are the examples that are taken from NCERT, so they are very important. And if it is carried over in the presence of electricity, then it is electrolysis of water. Every reaction we have to balance. These are the very important reactions. This is decomposition reaction. Going forward to the next type of reaction, that is called displacement reaction. As the name suggests, a more reactive element displaces less reactive element from its compound or its solution. This takes place on the basis of reactivity series, and the major part we have to learn this reactivity series so that we can use displacement reaction. How can we learn? A trick I have given in this video, this slide, that is, please stop calling me a zebra. I love her cute mind which is smart and genius, which is and is hidden words. Please stop calling me a zebra. I love her cute mind which is smart and genius. Every first letter I have taken for potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, that is a non-metal, copper, mercury, silver and gold. And this series is arranged in decreasing order of their reactivity. Means potassium is the most reactive and gold is the least reactive. So potassium will replace any of the metal that is present below potassium, and gold is the least metal that we have to do. This is not full reactivity series, this is the reactivity series that is commonly used. Continuing to the next slide, we'll have next type of reaction that is similar to displacement, but what is the difference? That is called single displacement reaction. This is called double displacement. In this reaction, mutual exchange of ions takes place. If you see the example carefully, you will understand easily that in this reaction we have two compounds exchanging their ions mutually. Sodium is exchanging with chlorine, barium is exchanging with sulfate. Thus, this is called double displacement reaction. Negative charge exchanging with positive charge. In this reaction, there is no requirement of reactivity series. Continuing to the next one, that is redox reaction. As the name suggests, it is the combination of oxidation and reduction. RED stands for reduction, OX stands for oxidation. Reaction in which reduction as well as oxidation takes place simultaneously. This is called redox reaction, and almost reaction that is taking place in chemistry is an example of redox reaction. There are few exceptions also. What is oxidation? It involves gain of oxygen or loss of hydrogen, or reduction, opposite of the same, the process in which gain of hydrogen takes place or loss of oxygen. Oxidation, as the name suggests, the spelling is there, addition of oxygen, and if oxygen is removed, it is called reduction, means something is being reduced. Oxidation is the addition of oxygen, reduction is the removal of oxygen. and redox is the combination of oxidation as well as reduction both. One example I have given right hand side, copper oxide plus hydrogen gas, arrow, heat is there, copper plus water. Here both the reaction is taking place, oxidation, reduction. How can we identify? See the black dot line, you will see that copper oxide, the oxygen is being reduced and it will become copper, and hydrogen, the oxygen is being added, it will become water. And water oxidizing and reducing agent, the agents are always present in the reactant side. Remember, this is the trick. The agents are always present in reactant side. Oxygen is present, that is called oxidizing agent. No oxygen is present, that is called reducing agent. What is oxidizing agent basically? In technical terms, the substance which give oxygen to the second substance, that is called oxidizing agent. Reducing agent, the substance which has taken oxygen from the first agent, that is called reducing agent. The agent which reduces or oxidizing agents are the agent which oxidizes. When we have to go somewhere, we take tickets from traveling agent. So traveling agents are the agents who take our tickets, who stand in line to buy our tickets. Same, oxidizing agents are the agents who give their oxygen to someone else so that they can be oxidized, and reducing agents are the agents which take oxygen from someone. Continuing to the next one, we have applications of oxidation. One is corrosion, second is rancidity.